because if you leave it for a few minutes, in order to conserve battery power, it tends to shut off. Of course, naturally, this is plugged into the to an AC adapter right now, so it's not actually using battery power, but it still automatically kind of shuts off when it's not being run after a few minutes. So, because I don't know whether you could see it, there's a gigantic X with a little black spot in the center of it there. I hope this doesn't mean that my telescope will end up being X-rated. Terrible joke, but it had to be said. Just think, I'll be one of the X-Men. Pardon me, X-Men. That's good. Okay, what I'm doing now, just kind of swiveling it around, kind of breaking it in a little bit. Maybe I'll use a few little 1/3 strokes or shorter strokes just to kind of make sure that the tool is functioning. Okay, I'm just stroking it around a little. I did this for about 5 minutes or so before I did the first figuring step with rouge, and it ended up there was quite a bit of optical roughness, like large primary and micro ripple, on the surface of the mirror at the end of the last large massive figuring step with Barnsight. After this little step with rouge, the surface was just as smooth as silk. You would not believe how a little bit of action with rouge removed the micro ripple from left by the Barnsight. It was just wonderful. Now what I do is I have to make complete circuits of the mirror. You don't judge it by the amount of polishing at time. You judge it by how many times you circle the mirror. So you have to make complete circuits of the mirror. So what I do is I always start out at the north end, which is just almost exactly the way the camera is facing toward the north. So I start right about here, and I'm going to start polishing like without any pressure on the tool. Start from about here and work with about 6 zigzag strokes back toward the edge of the mirror. I can't actually see the edge of the mirror, but I can estimate where it is. Okay, and you don't use any pressure, you just use the weight of the tool. See, like this. And according to Texroll's book, the strokes are about 1/3 the diameter of the mirror. But they might not be that long, depending on how brave you are when you're coming close to the edge. Now what I do is I rotate this, like, let's see, I'm getting a little confused here. The last time I did it the other way, but there, see, I started in a new position here. It's getting a little stiff, but you just have to persevere with it. I won't be talking too much while I'm actually doing this. See, I rotate this way, and I'm going to rotate it back this way, so I won't be rotating it quite so much. But it'll still get a new diameter of the tool on the new chord of the mirror. I'll be concentrated on the actual action now, so you can see how useful these little tabs are at the edge here for holding on to the tool while you're polishing in this unusual position. There. It's working out very well. I'm hoping by rotating the tool backwards like that I won't be going over the edge of the mirror quite so much, and it might have less of a tendency to turn the edge of the mirror. Maybe not, but I'm hoping. It's getting very stiff now. It's probably drying out a little bit. What I'll do is just kind of wiggle it around, as you can see, just kind of breaking it in a little bit again. Then I'm going to let it cold press for a little bit, maybe add some more water. You're supposed to keep it fairly free moving if you can while you're doing this kind of polishing work. Hope I remember, I think this was the spot I was going to start right here. I hope so. It's starting to wiggle now, rotate a little, so I'm going to make sure these things are clamped in good. To use a little bit more force now, I think. There. It's seizing up a little bit on me, but not bad. So what I'm going to do is right at that point, just a little bit beyond due east that way, I'm going to move this back in the center and let it cold press, because as you can imagine, polishing with a fairly soft pitch flap right near the edge of the mirror is going to distort the center of the pitch flap very rapidly. So what I'll do is, I usually go around the circuit maybe once or a little bit more, maybe 1/3 times, and then I cold press it. But right now, because I'm talking and I'm a little slow, I'm going to cold press it for a minute or two right now and just add a little bit more of this fluid to it. Mostly it's just water that I'm adding now. because there's plenty of rouge on there. Textural says that the polishing action is the most efficient when rouge and water are used sparingly. So you don't really need much polishing agent. But I like to use, pardon me, lots of water on it to keep it flowing smoothly, but you don't really need all that much rouge. It still seems to polish quite effectively. This action is not severe, by the way. It might take several hundred circuits of the edge of the mirror like this, possibly, to parabolize it altogether. But it's much easier work from a physical standpoint than it is doing it this way, than it is to, much easier to do it like that, than it is to use Barnsite and polish with long strokes. That just really kills you. Now I'm just a little bit beyond due east, so I think I can, maybe I'll just press down for a second or two, just try and get the lap back into shape, make sure that it's within the boundaries of the mirror. As you can see, the pitch lap was a little bit smaller than the mirror. I think the actual diameter is about 18.5 inches, and the mirror is almost 20. It's actually, the optical pace is 19.8, right up to the bevel. So there's a little bit of leeway there, which is actually good for this type of work, because then you can, it's very easy to keep the pitch lap within the edge of the mirror. I'm just pushing down with a few pounds force here, just to try and hasten the conformity of the pitch to the surface of the mirror. After I go around a little bit more, maybe one more, maybe up to the beginning again, I'm going to show you what it's like to do the other polishing stroke by Texroll. Okay, and that's where you hollow out the center of the mirror. And this is the method I used to parabolize my 12-inch mirror more than 30 years ago, and it ended up with a very accurate optical surface. It's capable of showing the disk shape of the asteroid Ceres under good seeing conditions, and also the disk shape of Titan, Saturn's largest moon. So I'm hoping to get this mirror of a similar accuracy. I probably won't, but I'm going to give it a try anyway. But it also ended up with a severe turn-down edge about 1/4 of an inch wide and the 12-inch that I had to mask off. It was originally a 12.5-inch blade. So that should be good enough for demonstration purposes, at least. Probably gets it pretty good. Now I just start a little bit beyond here, a little bit beyond the due east. Oops, I rotated it the wrong way. It's hard to get it just precise, and it's not really necessary to get it absolutely precise. I've completed one rotation now, like one revolution I should say, around the edge of the mirror. And what I'm going to do is let it cold press just for a few seconds, and what I'm going to do is support the overhanging part of the tool with one hand under one of these tabs, and press down with the other, and move that area of accented pressure with my right hand back and forth over the center of the mirror with strokes about 1/3 the diameter of the mirror. And that will tend to remove glass from the center area of the mirror. That's part of the parabolizing procedure, which I don't want to get into too deeply right now because I'm still trying to remove the edge, but I'm just going to do this for demonstration purposes to show you how it works. I'm starting out in the same way with the actual polishing action facing toward the north. That way I won't forget. And then according to Texroll's book, it's a little bit vague, but you more or less have to, you just start out like this and give sideways strokes. So I'm just supporting it with my left hand and pushing down with my right like this. I don't think I'm using an awful lot of pressure. I use about 6 strokes for consistency. Then I just rotate it that way a bit. Use 6 more. It's not as hard as it looks. Actually, it's very easy, really, compared to the work I've been doing on it. The edge of the lap becomes, in effect, a small tool. But it's much better than that, a small tool, because the rest of the lap actually contacts the mirror and helps it blend in the zones. See how I'm doing that? I might need to use slightly longer strokes. I'm not just sure. I'm not paying quite as much attention as I usually do, but that looks pretty good right there, the pattern I'm making now. I usually tend to polish away from the edge. like if the edge of the tool is this way, I tend to move the mirror that way as I zigzag. Using this method, the edge of the tool doesn't plow into the mirror, so to speak. Then I kind of forgot about that. You see how I'm moving it to the left as I'm polishing. See that? Rotate this to a new tab. Now. I moved it to the left. Now I've done a complete circuit. See, I'm ended up right here, just before here. So now I'm going to let it, I may just go around once more, just for illustrative purposes. Textural said this method is very effective. Avoid making a severe cavity in the mirror or something like that. This is a very effective way of removing glass from the center of the mirror, believe it or not. With a large mirror like this, it'll take a while. See how I'm moving to the left as I'm stroking? See that? You can't do it precisely every time exactly the same way, which is good. Because that way the law of averages will take over. And since I'm using rouge, it's not removing very much glass with each pattern, so it's starting to dry out a little bit now, so I'll have to add some more polishing agent. There. There we are. Now I'm going to cold press for a minute or two again to break in the surface. Get it accurately, press it accurately against the mirror and add a little bit more of this fluid here. You can see it's going to use quite a bit of fluid. Now I've done 2 circuits in the center and 1 around the edge. Today I'm going to try and do about 20 circuits all together around the edge to remove the high zone. It doesn't work all that quickly, which is a good thing. You don't want it working too quickly, because then the law of averages take over, and you tend to get a smoother surface than if you're removing glass at an alarming rate of speed. So a little bit of rouge comes out with this too, because it tends to mix up just slightly. But there we go. Pardon I've got a slight case of the flu, as I mentioned, so my throat, I might have to cough once in a while. Pardon my Jed Clampett costume that I'm wearing. I'm wearing that because this rouge has a deadly potential of staining clothing. If you get any on your clothes, you'll never get it off. So it's very, very, creates stains very easily. So I'm going to monitor this, by the way, and there's another principle you can use if you get a badly turned edge that's quite wide. See, I don't want to leave it there. And the edge is still, the inside is still raised a bit. You can actually, just like I did with the edge of the tool, instead of putting it near the center of the mirror, you can put the edge of the tool, say right here, with accented pressure, right up in this little area, right near the edge of the mirror, between where the hump is, where the raised zone turns into the turned edge, and move it back and forth a little, and that'll tend to reduce the turned edge relative to the profile of the entire mirror. And you can actually treat any raised zone in that way, just by knowing where it is, by using the values you get from the Coude screen. I call it like the Coude mask on the Foucault test. You find out where the high areas are, and you can use the edge of the tool as a sort of a carpenter's plane, you might say, to plane off the high areas as you go around. By the way, at the end of polishing, because I had the mirror on top, there was no astigmatism that I could detect. The optical surface was what you call a perfect figure of revolution. That is, if you take a diameter of this